All right, so the expectation for all 5 of these problems is that you should be able to find the derivative using your basic derivative rules. So for example, 3x to the 7th plus the square root of 3 times x squared minus e, if I want to take that derivative, well, we're going to use a combination of the sum and difference rules to just say, let's take the derivative of each term. I need to find the derivative of 3x to the 7th, plus I need to take the derivative of the square root of 3 times x squared, minus I need to take the derivative of e. Great, the sum and difference rules just allows me to take the derivative of each term one by one. The derivative of 3x to the 7th is the same thing as saying 3 times the derivative of x to the 7th plus, let's see, square root of 3 times the derivative of x squared minus the derivative of e. I didn't really plan my spacing well enough here. Well, the derivative of x to the 7th, that's when you're going to use your power rule. With the power rule, you bring the power down in front and reduce the power by 1. That would give you 7x to the 6th. Because this whole thing is being multiplied by 3, your final answer is 21x to the 6th. Okay, if I want to take the derivative of x squared, that derivative is 2x. So the square root of 3 times 2x is the same as 2 square roots of 3 times x. Minus, e is a constant, that's Euler's number, that's 2.718, blah, 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 blah. Derivative of any constant is 0, so my final answer for the derivative is that one. Done. I don't expect that many students at this point in the course are writing out the derivative one term at a time. Most folks have just gotten to the point where they know bring the power down and multiply, reduce the power by 1. Bring the power down and multiply, reduce the power by 1. That's a constant. The derivative of a constant is 0. But I wanted to make sure that at least one time on the video we went through and we did do this step by step. So that takes care of that one. Okay, g of x is equal to 1 over the square root of x. Well, we could use the quotient rule. We haven't covered that in the video yet, but instead I want to really focus on that algebra and getting it algebra ready. And what I mean by that is I know from algebra 2 that the square root of x is the same thing as x to the 1/2 power. I also know, using my rules for exponents, that 1 over x to the half is the same as x to the negative 1/2 power. Now that I have this showing up as x to a power, I can find the derivative using the power rule. We bring the power down in front. We reduce the power by 1. Negative 1/2 minus 1 is negative 3/2. So your final answer would be negative 1/2 x to the negative 3/2 power. That's great. That's accurate. However, if you want to go further with your reducing, make it 1 over 2, and then it's x to the 3/2 power. If x is being raised to the 3/2 power, the denominator means, since it's a 2, you're going to take the square root. The numerator is a 3, you're going to raise it to the 3rd power. So you could also write your answer as negative 1 over 2 square root of x cubed. This answer is perfectly acceptable, as is this one, as is that one. They're all great. They're all perfectly correct. On the multiple choice test, though, multiple choice portion of the test anyway, you need to be ready for all 3 to show up. All right, let's do L of x. L of x, well, let's get this in derivative ready form. Square root of x we know is x to the 1/2. Cubed root of x is actually x to the 1/3. 1 over the square root of x is x to the negative 1/2. If I want to take a derivative, we're going to use the power rule 3 times. Bring the power down, reduce the power by 1. Plus, bring the power down, reduce the power by 1. Plus, bring the power down, reduce the power by 1. If you did that derivative correctly, you have 1/2 x to the negative 1/2 power, plus 1/3 x to the negative 2/3 power, minus 1/2 x to the negative 3/2 power. Let's look at m of x. M of x is x times the cubed root of x. Well, let's rewrite that as x times x to the 1/3 power. One of the algebra rules that I have to have handy here, when I am multiplying, the bases are the same. We add the exponents together. 1 plus 1/3 is 4/3. Take the derivative using the power rule, bring the power down, reduce the power by 1. 4/3 minus 1, 1/3. Done. Or you could write it as 4/3 times the cubed root of x. Okay, last one for this portion of the video. We have n of x equal to x minus 4x cubed over the square root of x. My advice would be, since you have just one term in the denominator, break it up. Make it x over the square root of x minus 4x cubed over the square root of x. I haven't done any calculus, I'm just doing algebra. Now let's get rid of those radicals. X over x to the 1/2 minus 4x cubed over x to the 1/2. Another algebra rule here. I have the bases are the same. When the bases are the same, and you're dividing, we subtract the exponents. The exponent up here is a 1. So x to the first divided by x to the 1/2 is the same as x to the 1/2 power minus 4 x cubed divided by x to the 1/2. 3 minus 1/2 is 2.5. As an improper fraction, that's 5 over 2. I still have not taken a derivative, so we're going to finally get to take a derivative. We're going to use the power rule. Power rule says bring the power down, reduce the power by 1. 1/2 x to the negative 1/2 power minus 4 times 5/2 x to the 3/2 power. 4 times 5/2, what is that, 20 over 2, that's 10. So we have 1/2 x to the negative 1/2 power minus 10 x to the 3/2 power. And we are done with those problems. We're going to move on now to product rule and quotient rule. Done.